Mathematics in our world. Patterns and numbers in nature in the world. Patterns in nature are visible regularities of form found in the natural world and can also be seen in the universe. Nature patterns are not just to be admired. They are vital clues to the rules that govern natural processes. We can define patterns as regular, repeated, recurring forms of design, identity relationship, find logical connections to form generalization and prediction. For example, patterns can be observed even in the stars which move in the circle across the sky each day. The season cycle each year, all the snowflakes contain six-fold symmetry which no two are the same. Patterns can be seen in fish pattern like spotted trunkfish, spotted puffer, blue spotted stingray, spotted moray eel, coral grouper, red lionfish, yellow boxfish, and anglefish. These animals and fish stripe and spot attest to mathematical regularities and biological growth and form. Zebras, tigers, cats, and snakes are covered in a pattern of stripes. Leopard and hyenas are covered in a pattern of spots, and giraffe are covered in a pattern of blotches. Natural patterns like the intricate waves across the ocean, tones on desert, formation of the typhoon, water drop with ripples, and others. These serve as clues to govern the flow of water, sand, and air. Other patterns in nature can also be seen in the ball of mackerel, the bee formation of geese in the sky, and the tornado formation of starling. Types of patterns: symmetry, fractals, spirals, and tessellation. Symmetry is a sense of harmonious and beautiful proportions of balance or an object in a variant to any various transformations, reflections, rotations, or scaling. There are two types of symmetry, the bilateral symmetry and radial symmetry. Bilateral symmetry is a symmetry in which the left and right side of the organism can be divided into approximate mirror image of each other along the middle. Like for example, mirror image of sunflower, bugs, and butterfly. Radial symmetry or rotational symmetry is a symmetry around a fixed point known as the center and can be classified as either cyclic or dihedral. Plants or rotational symmetry as the flowers and some group of animals. Same for example, dihedral D5 symmetry of starfish, sea urchins, and sea lilies. Dihedral D4 symmetry of jellyfish, and radial symmetry of different kinds of flowers. Fractals is a curve or geometric figure, each part of which has the same statistical characters as the whole. A fractal is a never-ending pattern found in nature. The same shape is replicated in a process called self-similarity. The pattern repeats itself over and over again at different scales. Like same for example, a tree grows by repeated branching. This kind of branching can also be seen in lightning bolts and the veins of our body. Spirals is a logarithmic spiral or growth spiral is a self-similar spiral curve that often appear in nature. A spiral is a curve pattern that focuses on a center point and a series of circular shapes that revolves around it. Like same for example is spirals in pine cones and millipedes. Tessellation are patterns formed by repeating tiles all over the flat surface. The arrays of hexagonal cells in a honeycomb or the diamond shape in a pineapple are natural examples of tessellation patterns. The Fibonacci sequence. Who discovered the sequence? Leonardo Pisano, also known as Leonardo of Pisa, which means from Pisa. He was also known as Fibonacci, which means son of Fibonacci. He was considered to be the most talented Western mathematician of the Middle Age. What is Fibonacci sequence? The Fibonacci sequence is a series of numbers where each one is added to one before it. The Fibonacci sequence is a famous series of numbers with a pattern. The pattern is that every number is added to one before it. Here's the first few part of the sequence. Same for example, 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, 233, 337, and so on. As you can see, 1 plus 1 is equals to 2, 2 plus 1 is equals to 3, 3 plus 2 is equals to 5, and so on. It's a really simple progress and can go on forever. What impressive about this sequence is that you can get a spiral if you turn those numbers into boxes. Take a look at this image below as an example. There are also Fibonacci sequences in nature, like Fibonacci spiral in sunflowers, Fibonacci sequence in pine cones, and Fibonacci sequence in flowers. Mathematics for organization. A lot of events happen around us. Several children have already been born. Liters of water have been consumed, and thousands of comments, pictures in FB have been posted. For us to make sense of all available information, we need mathematical tools to help us sound analysis and better decision. Say for example, a particular store can gather data on the shopping habits of its customer and make necessary adjustments to help drive sales. Scientists can plot bird migration routes to help conserve endangered animal populations. Social media analysis can crunch all online posting using software to gauge the netizens' sentiment and particular issues or personalities. Mathematics for prediction. It is something said that history repeats itself. As much as we can use mathematical models using existing data to generate analysis and interpretation, we can also use them to make prediction. Applying the concept of probability, experts can calculate the chance of an event occurring. Say for example, the weather is a prime example based on historical patterns. Meteorologists can make forecasts to help us prepare for our day-to-day activities. They can also warn us of weather disturbances that can affect our activities for weeks or months. Mathematics for control. We have demonstrated by means of example around us that patterns are definitely present in the universe. There seems to be an underlying mathematical structure in the way that natural objects and phenomena behave. The following observation of nature, as well as their interaction and relationship, could be more elegantly described by means of mathematical equation. Photographers could capture a single moment through a snapshot. Videographer could record events as they unfold. Painters and sculptors could create masterpieces in interpreting their surroundings. Poets could use beautiful words to describe an object. Musicians could capture and reproduce sound that they hear. Same for example, in 1916, Albert Einstein hypothesized the existence of gravitational wave based on his theory of general relativity. This is when ripples are formed in the fabrics of space-time due to large and violent cosmic events, very much like when pebbles is thrown on a stagnant pond. Mathematics is indispensable. It was highlighted how mathematics play a huge role in the understanding of our world. We have seen it in living creatures and natural phenomena. At the most basic level, logical reasoning and critical thinking are the crucial skills that are needed in any endeavors. As such, the study of mathematics should be embraced as it paves the way for more educated decisions and in the way for more educated understanding the natural world.
Mathematical language and symbols. Language is a systematic way of communication with others that involves the use of sounds or convention symbols. Here are the characteristics of mathematical language. The language of mathematics makes it easy to express the kinds of thoughts that mathematicians like to express. It is precise, able to make very fine distinctions, concise, able to say things briefly, powerful, able to express complex thoughts with relative ease. Expressions versus sentence. An expression is the mathematical analog of an English noun. It is the correct arrangement of mathematical symbols used to represent a mathematical object of interest. Example: number, set, function, and ordered pair. While mathematical sentence is the analog of an English sentence, it is the correct arrangement of mathematical symbols that state a complete thought. A sentence can be always true always false, or sometimes true, sometimes false. Example, 1 plus 1 is equal to 2 is true. 1 plus 5 is equals 8 is false. X is equals 5, sometimes true and sometimes false. Conventions in mathematical language. Mathematics has its own language. There are many symbols in mathematics, and most are used as a precise form of shorthand. Here are the two things context the particular topics being studied. Number 2. Convention, where mathematics and scientists have decided that particular symbols will have particular meaning. Common mathematical symbol. The words associated with the symbol are plus, add, increase, or positive. These symbols are minus, subtract, take away, negative, and decrease. These symbols are multiply, lots of, and times. These are the division symbol and the equal signs and its variants. This sign, which means is not equal to, is approximately equal to. This sign means is greater than or equal to. This sign means is less than or equal to. The Greek alphabet. You will find that Greek letters are used in many calculations. For example, the Greek letter pi, written like this, is used to represent the number 3.14159 and so on. This number continues forever without repeating. Other mathematical symbols. Almost all mathematical statements, relations, operations are expressed using mathematical symbols. Here are some mathematical symbols that can be used for basic concepts in mathematical language. We have sets, functions, relations, and binary operations. Each set is a collection of distinct objects called elements of the set. A set can be defined by describing the content, or it can be represented by listing the elements between braces. Example, set A and or elements 1, 3, 9, 12, 15, 18. This is the set of all even numbers. Set B and or elements A, E, I, O, U are the set of vowels. Set Browser notation. If S is a set, the notation will be X is an element of S and X is not an element of S. A set may be specified using the set Browser notation by writing all its elements between braces. Examples of set Browser notation. An elements 1, 2, 3, and so on to 100 denote the set of all the integers from 1 to 100. This notation used to describe the very large set. And number 2 is in elements 1, 2, 3, and so on. Refer to the set of all positive integers. The symbol like this is called an ellipsis and grid and so forth. Set builder notation. Let S denote the set and let P of X be a property that elements of S may or may not satisfy. We may define a new set to be the set of all elements X in S such that P of X is true. We denote these sets as follows. These symbols means the set of all and such that. The example of set builder notation, given that say or denotes the set of all integers, this is the set of all elements X in the set of all integers such that greater than -4 but less than +3. This is the set of all integers between -4 and 3. It is equal to -3, -2, -1, 0, 1, and 2. Subset. Set A is a subset of set B if all elements of A are also present in set B. It is denoted by the symbol like this and read as is a subset of. If A is a subset of B, we write like this. It follows from the distinction of subset that for set A not to be a subset of A, set B means that there is at least one element of A that is not an element of B. Legally, A is not a subset of B. Proper subset. Set A is considered to be a proper subset of set B if set B contains at least one element that is not in set A. A proper subset is denoted by this symbol and read as is a proper subset of. If A is a proper subset of B, we write like this. For example, set A and elements are 1, 2, 3, and 4. The possible subsets are the following. We have all elements, some elements, and no elements. All of these are the possible subsets. And also, these some elements and no elements are also a proper subset. While these all elements are not a proper subset because this element is also an element of the given set. Universal set. Universal set is the set of all elements. It is denoted by the symbol like this. For example, if set A and our elements 1, 2, 3, 4, and 5, and set B and our elements 5, 6, 7, then the universal set is 1, 2, 3, 4, 5, 6, 7. Always remember that in universal set, it is without repetition of elements. The empty set or the null set is the set that contains no elements. It is denoted by the symbol like this. The union of A and B is the set of all elements in A and all the elements in B. The union is notated like this. Example, set A and the elements are 1, 2, 3, 4, 5, and set B and elements are 5, 6, 7. Now, the union is elements
1, 2, 3, 4, 5, 6, and 7.
Complement. The complement of a set A contains everything that is not in the set A. The complement is notated like this or sometimes like this. Example, universal elements are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Let A 1, 2, 4, 5, B, or the elements are 2, 3, 4, 5, 9, 10. Now, let's get the complement A equals to 3, 6, 7, 8, 9, and 10. The complements of B are elements of 1, 6, 7, and 8. Intersection. The intersection of two sets contains only the elements that are in both sets. The intersection is notated like this. A intersects B. For example, set A and our elements 1, 2, 3, 4, 5, and set B and elements are 5, 6, 7. So now let's find the same elements of set A and set B. So the A intersect B is elements of pi relation. A relation is a rule that relates from a set of values domain to second set of values range. A set or collection of ordered pairs x and y. This is the domain and this is the range. For example, a relation R have a set of ordered pairs 2, 1, 3, 2, 4, 5, 6, 8, 7, 9. Our domain and range are follows. Our domain are 2, 3, 4, 6, and 7. While our range are 1, 2, 5, 8, and 9. Function. Function is a relation in which no two ordered pairs have the same first element. Function can be represented in different ways. Which of the following relations are functions? A relation M have a set of ordered pairs 3, 2, 4, 5, 6, 8, 2, 9. This is a function because every x value is unique and is associated with only y value. Next, a relation N have a set of ordered pairs negative 3, 6, 4, 5, 6, 2, 6, 9. This relation is not a function because we have a repetition of x values. Examples of how to determine if a relation is a function. A relation is a function if it is one-to-one, like this, many to one, and it is not a function if it is one-to-many and many-to-many. Binary operation. Binary operation is an operation that requires two inputs. These inputs are known as operands. The binary operation of addition, multiplication, subtraction, and division takes place on two operands. And now I will show you how to solve binary addition and subtraction. First, we solve the binary addition. It can be calculated easily if we know the following rules. Are the rules of the binary addition. We have 0 plus 0 is equal to 0, 0 plus 1 is equal to 1, 1 plus 0 is equal to 1, 1 plus 1 is equal to 10. For example, 1, 0, 1 plus 1, 1, 0. First, we need to add the first column. 1 plus 0 is 1. 0 plus 1 is 1. 1 plus 1 is 10. So, to check our answers, let's convert each number into a decimal number. So, this is 1, 2, 4, and 8. If there is 0 digits, we need to cancel it. So after that, we will add the numbers. 4 plus 1 equal to 5. 4 plus 2 equal to 6. Then add 5 plus 6, 11. We will do the same in our answers. We have 8 plus 2, 10 plus 1 is equal to 11. Binary subtraction. Here are the rules for binary subtraction. For example, we have 0, 1, 1 minus 0, 1, 0. So let's subtract the first column. 1 minus 0 is 1. 1 minus 1 is 0. 0 minus 0 is 0. Elementary logic, connectives, quantifiers, and negation. First, let's define logic. Logic is the study of how to critically think about propositions or statements that are either true or false. Logic is very useful in the world of mathematics. Mathematicians use logic all the time to prove theorems and other mathematical facts. Logical connectives. The word and, or, but, if then, if and only if are examples of logical connectives. They are words that can be used to connect two or more simple statements to form a more complicated compound statement. The symbol P, Q, R, and S represent simple statements. The first simple statement, it is raining. The second simple statement, the ground is wet. And the compound statement is, it is raining and the ground is wet. I use connected and in this compound statement. Symbols used for connectives. Quantified statements. The words all, some, and none are examples of quantifiers. A statement containing one or more of these words is quantified statement. Note, the word some means at least one. Example, some cats are mammals. Negation. If P is a statement, the negation of P is another statement that is exactly the opposite of P. The negation of a statement P is denoted like this, means not P. If the example of quantifiers are all, some, none, and etc., the negation is the opposite statements. Example, the quantified statements some A are B, the negation of that no A are B. The quantified statements no A are B, the negation of that some A are B. Let's define what is formality. According to Helene F. D. Whale, GM in the formality of language, definition, and measurement, an expression is completely formal when it is context-independent and precise. That is, it represents a clear distinction which is invariant under changes of context.
Data. Gathering and organizing data. Representing data using graphs and charts. Interpreting organized data. What is data? Data is collection of information from facts, statistics, numbers, characteristics, observations, and measurements that represent an idea. There are two forms of data. Quantitative data deals with the quantity. For example, the number of whales at SeaWorld. Qualitative data is another form of data that deals with the description of things. Qualitative data can be observed but not measured, such as color of eyes. Gathering and organizing data. You may be wondering, how do we gather data? There are several ways to obtain and analyze data. As a researcher, you can use the following: surveys, focus groups, interviews, and questionnaires. Survey is a tool that a person can use to have a brief discussion about a specific topic, like favorite ice cream flavor. Have you heard that a picture is worth 1,000 words? The organization of your data is critical when you're trying to explain the result from a research topic. Let's review some visual representations of group data. Let's examine the bar graph. A bar graph is a graph with group data that has vertical or horizontal bars. Data interpretation is the process of going over data and applying established methods to it in order to assign meaning to it and come to a suitable conclusion. It entails taking the results of data analysis, drawing conclusions from the relationships investigated and applying those inferences to get a conclusion. So, organizing and interpreting data. Before conducting an investigation, it is important to learn how to organize the data you have collected. After you have organized the data, you need to make sense of what you have observed. Data tables and charts are usually the way scientists organize their data. What is mean? A mean is the simple mathematical average of a set of two or more numbers. When we say mean, we always remember the word average. So, this is the symbol. Sample mean equal summation x over n. So, this is the example. Find the mean of the following set of scores: 20, 50, 30, 10, 18, and 40. To find the mean, we need to add all the scores divided by the number of score. 20 plus 50 plus 30 plus 10 plus 18 plus 40 equals to 168 divided by 6. So the final answer is sample mean 28, that is the mean of the score. When we say median, we always remember the word middle. Here's the example: 48, 30, 42, 12, 50. To find the median, we need to arrange all the scores which is descending to ascending sequence, so we have 12, 30, 42, 48, and 50. The middle scores is 42, so the median is 42. What is mode? The mode is the value that appears most frequently in a dataset. When we say mode, we always remember that these are the score with greatest frequently. In example number 1, we have 2, 6, 21, 3, 8, and 7. In this example, there is no mode because all frequencies are equal. In example number 2, we have 44, 48, 44, 55, 68, and 70. The mode is 44 since it's the score that frequently appears. The distribution is said to be unimodal. In example number 3, we have 10, 10, 6, 2, 4, and 2. The modes are 10 and 2. Since the distribution has two modes, it is said to be bimodal. If it has many, it is multimodal. What is weighted mean? The weighted mean is a type of mean that is calculated by multiplying the weight or probability associated with a particular event or outcome with its associated quantitative outcome, and then summing all the products together. Here we go again. The easiest way to find weighted mean in the sample. All the percent values must convert into decimal numbers. So 10% is equal to 0.1, and then 70% is equal to 0.7, then 10% is equal to 0.1, 65% is equal to 0.65, 30% is equal to 0.3. So 70% is equal to 0.7. 50% is equal to 0.5. Then 85% is equal to 0.85. All decimals are multiplied. So 0.1 times 0.7, then 0.1 times 0.65, then 0.3 times 0.7,
and 0.5 times 0.85. And you add the all numbers and multiply by 100. Okay, so equals 0.07, 0.065, 0.21, and then 0.425, and add. So 0.77 and multiply by 100 is equal to 77, and this is the answer. So 77 is the weighted mean. Thank you.
What is range? The range is the difference between the highest and lowest values in a set of numbers. To find it, subtract the lowest number in the distribution from the highest. Range is the difference between the highest and lowest values. Use this. Range equals highest value minus lowest value. In the given example, we have 10, 12, 8, 15, 20, 25, 5, 16, and 7. We find first the highest numbers, which is 25, and the lowest number is 5. To find the range, we need to look for the difference of 25 and 5. So the range is 20. What is standard deviation? Standard deviation is a statistic that looks at how far from the mean of the group of number is by using the square root of the variance. Using this formula, standard deviation equals summations of deviations from mean squared over n minus 1. Find the standard deviation. Add all the given score divided by the number of scores. In this sample, 10 is the mean. Step 2. Construct a table of values. This is a table of values. Step 3. Substitute in the formula. What is variance? The term variance refers to a statistical measurement of the spread between numbers in a dataset. Sample 1. Find the variance of the following data using the variance formula.
I will be discussing the measures of relative position. A measures of relative position is a statistical measure that provides the specific location of an observation relative to the other values when the data are in ranked order. This measure divide the data sets into subgroups such that a specific portion of the set belong to the lower bracket and the remaining on the higher bracket. Among the most commonly used measures of relative position are percentiles, deciles, and quartiles. Percentile. It is denoted by big letter P and small letter I. Is a value that divides an array of observations into 100 equal parts in order that I% of all the observations lies below percentile. Quartile. It is denoted by big letter Q and small letter I. Unlike the percentile, it is a value that divides an array of observations into 4 equal parts in order that I by 25% of all the observations lies below quartile. Decile, denoted by a big letter D and small letter I, is a value that divides an array of observations into 10 equal parts in order that I by 10% of all the observations lies below decile. In determining the desired measure, the data must first be arranged in an increasing pattern. The entire set of observations in a percentile contains 99 partitions which are located at P1, P2, and so on up to P99, where 1% of the total observations are lower than P1 and the remaining 99% are higher than P1. Likewise, 2% of the total observations are found below P2 and 98% are above it, and so on. The quartile and decile can be determined by solving its equivalent percentile. For example, Q1 is equals to P25, Q2 is equals to P50, Q3 is equals to P75, and so on. On the other hand, D1 is equals to P10, D2 is equals to P20, D3 is equals to P30, and so on. Given a dataset, then median is equals to P50 equals to Q2 equals to D5. Formula for the percentile. The percentile P1 of ungrouped data consisting of n observations located on the ith place can be computed as P1 equals Ni over 100. Let's have an example. Given the following dataset 25, 5, 6, 12, 8, 16, 17, 22, 20, and 9. Compute for A. 20th percentile, B. First quartile, and C. Third decile. Solutions. First, we must arrange the scores in an increasing manner. It will become 5, 6, 8, 9, 12, 16, 17, 20, 22, and 25. First, we will solve for the 20th percentile. We have the given n, which is equals to 10. 10 is the number of scores from 5 to 25, and the I, which is equals to 20, because we're looking for the 20th percentile. We will use the formula P20 is equals to Ni over 100. We will replace the n with 10 and I with 20. After that, multiply 10 by 20, the answer is 200. Then divided by 100, the answer is 2. 2 is the location of the 20th percentile. This means that the 20th percentile is the second score from the lowest, which is 6. So P20 is equals to 6. Now we will look for the first quartile. We have the given n, which is equals to 10, and I, which is equals to 25, because the first quartile is equivalent to the 25th percentile. We will use the formula P25 is equals to Ni over 100. Replace n by 10 and I by 25. After that, multiply 10 by 25. The answer is 250. Then divided by 100 equals 2.5. P25 is located halfway between the second and third value in the list. By the way, 6 is on the second value, while 8 is in the third value, which is why P25 is equals to 7. Since Q1 is equals to P25, therefore Q1 is equals to 7. Next, we will solve for the third decile. We have the given n, which is 10, and I, which is 30, because the third decile is equals to 30th percentile. We will use the formula P30. P30 is equals to Ni over 100, then replace n by 10 and I by 30. After that, multiply 10 by 30, the answer is 300, then divided by 100, the answer is 3. The location of P30 is in the third value on the list, which is 8. Since D3 is equals to P30, therefore D3 is equals to 8. Box and whisker plot. A diagram showing the representation of a 5-point summary of a dataset is specified by the lowest and the highest values, the values corresponding to Q1 and Q3, and the median. The 5 important numbers are arranged increasingly in either a horizontally or vertical scale. It was also known as the box plot. Steps in the construction of box and whisker plot. First, arrange the values in an increasing pattern. Second, compute for Q1, median, and Q3. Third, we are to locate the 5 numbers, which is the lowest and highest values, Q1, median, and Q3, in the number line and draw a rectangle or a box above the scales covering Q1, median, and the Q3. Then draw a line segment across the box passing through the median. Connect the box to the extreme values by a line segment known as whiskers. Below is the sample format for a box and whisker plot. Probabilities and normal distributions. A normal distribution is a perfectly symmetric, mound-shaped distribution. If the mean, median, and mode of data coincide or equal to one another, we can say that the data is normally distributed. And if the data is normally distributed, it means that most of the data is densely concentrated towards its center. Below is an illustration of a normal distribution. Characteristics of a normal distribution. Number 1. The mean, median, and mode coincide or is equal from one another. Number 2. It has a bell-shaped curve. Number 3. Mean, median, and mode divides that curve into equal parts. That is the lower 50% of data and the upper 50% of data. Number 4. The curve is horizontally asymptotic, which means that the curve won't touch the x-axis. The empirical rule. Number 1. The area from negative 1.0, which is located on the left side of the curve, to positive 1.0, which is located on the right side, is equivalent to 68% of the total area. Number 2. The area from negative 2.0 to positive 2.0 is equivalent to 95% of the total area. And number 3. The area from negative 3.0 to positive 3.0 is equivalent to 99.7% of the total area. Let's have an example. Suppose the score of 250 students in a certain exam is normally distributed with the mean 30 and with a standard deviation of 6. Answer the following. Number 1. How many students scored less 25? Number 2. How many students have scores higher than 36? And number 3. How many students have scores from 24 to 44? First, we will be solving for the number of students who scored less than 25. It can be written as this. Solution. We already have the given x, which is equals to 25, the mean, which is 30, and the standard deviation, which is 6. We will be using the z equals x minus mean over s. First, we will replace the x by 25 and the symbol for mean by 30. Then the s, we will replace it by 6. After that, subtract 30 to 25. The answer is negative 5. Then divide negative 5 by 6. The answer is negative 0.8333 and so on, or approximately negative 0.8. Next is to locate the z in the table. And since the computed z is negative 0.83, we will be using a negative table for negative z score. But before that, we need to split it into negative 0.8 and negative 0.03. Then locate it on the table. Based on the table, the intersection is 0.20327 or 20.327%. The intersection represents the area or probability from left to the right of the normal distribution. As you can see on the table, the shaded part represents the area in the normal distribution from left to 0.83. And since the sample is 250, which is the number of students, 20.33% of them scored 25 or less. Therefore, 250 by 0.20327 is equals to 51. At most, 51 students scored less than 25. Next is to solve for the number of students who scored higher than 36. Solution. We have the given x, which is 36, the mean, which is 30, and the standard deviation, which is 6. We will use the same formula. First, replace the x by 36 and the mean by 30 and the standard deviation by 6. Next is to subtract 30 to 36. The answer is 6. After that, divide 6 by 6. The answer is approximately 1.00. Now split 1.00 to 1.0 and 0.00, then locate it in the table. This time, we will be using a positive table for positive z-scores. Based on the table, we will get 0.84134 or 84.134%. As you can see on the illustration below, the shaded part represents the area in the normal distribution from left to 84.13%. But we are to get the number of students with score of at least 36 or above. This means that the answer is in the other section, which can be get by subtracting 84.13% to 100%. The answer is 15.87%. Among the 250 students, 15.87% of them scored 36 or above. Therefore, 250 by 0.1587, the answer is 40. At most, 40 students scored at least 36 or above. Now we will be solving for the number of students who scored from 24 to 44. Solution. We have the given x, which is 24 and 44. By the way, ignore 36. That is 24, 24, and 44. We have the mean 30 and the standard deviation, which is 6. We will be using the same formula. First, I will replace the x by 24 and the mean by 30 and 6 for the standard deviation. Then subtract 30 to 24. The answer is negative 6. After that, divide negative 6 to 6. The answer is approximately negative 1.00. This time, I will be replacing x with 44, then the mean by 30 and 6 for the standard deviation. Now, subtract 30 to 44, the answer is 14. Then divided by 6, the answer is approximately 2.33. Based on the first computed z, I will be locating negative 1.0 and 0.00 on the negative table for negative scores, while on the second computed z, I will be locating 2.3 and 0.03 on the positive table for positive scores. As you can see on the illustration below, the covered area of negative 1.00 from left is 15.87% or 0.15866 from the z table. Hence, the covered area of 2.33 from left is 99.01% or 0.99010 from the z table. To get the area covered in between, we must subtract the smaller area. So 99.01% minus 15.87% is equals to 83.14%. Meaning, among the 250 students, 83.14% of them has scored from 24 to 44. Therefore, 250 multiplied by 0.8314, the answer is 208. At most, 208 students have scored 24 to 44. Linear regression and correlation. Correlation and regression are two related statistical tools. The correlation is used to find out if there is a relationship between two variables, while the regression is a means to predict or forecast the value of one variable in terms of the other. The relationship between two variables can be shown graphically by sketching the scatter diagram. A scatter diagram, or also known as a scatter plot, is a pictorial presentation showing the relationship between two variables. The line of most interest is called the line of the best fit, or the least square regression line. It is a line for a set of bivariate that minimizes the sum of the squares of the vertical deviations from each point of the line. Formula for the least square line. Given the ordered pairs of relative variables x1 and y1, x2 and y2, x3 and y3, and so on, the equation will be y hat equals ax plus b, where a is equals to n times the sum of x and y minus the sum of x multiplied by the sum of y over n times the sum of x squared minus the sum of x raised to 2, while b is equals to the sample mean of y minus a times the sample mean for x. As you all know, this symbol represents the mean of x variables, while this one represents the mean of y variables. Let us now determine the equation of the line which approximately model the relationship of the following points A, B, C, D, and E. Based on the table above, under x we have 1, 2, 3, 4, and 5, while under y we have 2, 3, 3, 6, and 4. To solve for xy, we must multiply all the numbers under x to the numbers under y. So 1 times 2 equals 2. Same with the others. 2 times 3 equals 6. 3 times 3 equals 9. 4 times 6 equals 24. 5 times 4 equals 20. Now, to solve for the x squared, we must multiply the numbers under x to themselves. Meaning, we must multiply 1 times 1. We get 1. Same with the others. 2 times 2 equals 4. 3 times 3 equals 9. 4 times 4 equals 16. 5 times 5 equals 25. Now, to solve for their sum. To solve for the sum of x, all we need to do is add all the numbers from 1 to 5. We get 15. Same with the others. The sum for y is 18. The sum for xy is 61. And the sum for x squared is 60. Now we need to know the sample mean for x. In order to solve for that, we must divide the number 15 by 5. We get 3. 3 is the sample mean for x. Now, to know the sample mean for y, we must divide 18 by 5. We get 3.6. 3.6 is the sample mean for y. Next is to solve for a. In order to do that, we must first replace all the symbol in the formula based on the table. It will now become a equals 5 times 61 minus 15 times 18 over 5 times 60 minus 15 raised to 2. First, multiply 5 by 61, the answer is 305. Then 15 times 18, the answer is 270. Then multiply 5 by 60, the answer is 300. Then 15 multiplied by itself, we get 225. Now subtract 270 to 305. The answer is 35. 300 minus 225, the answer is 75. Now we have to convert it into lowest term. We will get 7 over 15, or approximately 0.47. Next is to solve for b. Replace all the symbol in the formula. Now we will get b equals 3.6 minus 7 over 15 times 3. First, multiply 7 over 15, or 0.47 in decimal form, by 3. We will get 7 over 5, or 1.41 in decimal form. 3.6 minus 7 over 5 equals 11 over 5, or 2.2 in decimal form. Therefore, the equation of least regression line Given this equation is y hat equals 7 over 15x plus 11 over 5. This is 15 by the way. Or y hat equals 0.47x plus 2.2. Based on the illustration, the trend of the line is slightly increasing with stiffness or inclination of 7 over 15 or 0.47 per unit and y-intercept of 11 over 5 or 2.2. Linear correlation coefficient. It is used to determine the strength of a linear relationship between two variables, which is denoted by R. In terms of strength, the correlation may be perfect, high, moderate, or low. Likewise, in a perfect correlation, all points in the scatter diagram lie on a straight line. Given the ordered pairs of related variables x1 and y1, x2 and y2, x3 and y3, and so on, the equation will be like this. And if r is positive, as one variable increases, the other one also increases. And if r is negative, as one variable increases, the other one decreases. The closer the r to 1, the stronger the relationship of the variable. However, if r is equal to 0, meaning there is no correlation. The following points are the accepted guidelines for interpreting the correlation coefficient. As you can see, the 0 has no linear relationship. The positive 1 is interpreted as perfect positive linear relationship, while the negative 1 is interpreted as perfect negative linear relationship. If the r is between 0 and 0.3, or 0 and negative 0.3, it is interpreted as weak positive or negative linear relationship, while the numbers between 0.3 and 0.7, or negative 0.3 and negative 0.7, it is interpreted as moderate positive or negative linear relationship. The numbers between 0.7 and 1.0, or negative 0.7 and negative 1.0, is interpreted as a strong positive or negative linear relationship. Let us consider the same example. After determining the equation of the line the best fit to the given data, let us now determine the correlation of data. The first 4 columns were already filled in the previous solution. For this one, we need an addition column for y squared. In solving for y squared, we must multiply all the numbers in y by itself. So, 2 times 2 equals 4, 3 times 3 equals 9, same with this one, 3 times 3 equals 9, 6 times 6 equals 36, 4 times 4 equals 16. Then we solve for its sum. In order to do that, we must add all the numbers in y squared from 4 to 16. The answer is 74. Now, we will be solving for r. But first, we must replace all the symbol in the formula based on the table above. We will now get r equals 5 times 61 minus 15 times 18 over the square root of 5 times 60 minus 15 raised to 2 multiplied by the square root of 5 times 74 minus 18 raised to 2. First, multiply 5 times 61. The answer is 305. 15 times 18. The answer is 270. Then multiply 5 times 60. The answer is 300. 15 times 15, we get 25. 5 times 74, the answer is 370. Then 18 times 18, the answer is 324. Subtract 270 to 305, we get 35. Then 300 minus 225, the answer is 75. And 370 minus 324, we get 46. Next, convert the square root of 75 into simplest form. It will now become 5 times the square root of 3. After that, divide 35 by 5. It will now become 7 over the square root of 3 multiplied by the square root of 46. Then multiply the square root of 3 by the square root of 46. The answer is the square root of 138. Now divide 7 by the square root of 138, or 11.75. Or you can multiply 7 by the square root of 138, then divide it by 138. Either way, you will get the same result, which is roughly 0.60. Therefore, the computed R is positive 0.60, which means that variables have moderate positive linear relationship.